Hello and welcome to Linn HQ in Glasgow. Today we're going to be building a Climax LP12 turntable using the new Bedrok Plinth. Bedrock is quite a special material. It begins life as beech ply that are laid up, and then they are subjected to extreme pressure and temperature, and a little bit of resin is injected, and what comes out is effectively organic carbon fibre. But unlike carbon, it isn't light. The plinth, it's damping energy, negative energy that we want to eliminate, allowing the suspended side of the LP12 to be isolated from that external vibration or energy that we don't want to have interfere with the signal that the turntable is generating. That is why it is the next step on in performance from LP12. At the moment, I can fit my DC motor, Radikal II motor, into the corner top plate. The reason that we use a DC motor at climax level is that a DC motor outputs less magnetic radiation. That's also why on almost every turntable you'll see the motor is as far away from the cartridge as possible. I can exit the power cable out of the rear of the plinth. So now that we have our DC motor in place, we can fit our power switch and connect that to the motor. At the moment, I'm preparing the Keel sub-chassis to be fitted to the turntable. At the moment, I'm torquing the Karousel bearing to 3.5 Newton meters. Now we're going to get ready to fit the Keel sub-chassis to the plinth. I can take my springs and I can mount the suspension to the turntable. Now we can get ready to fit our wiring strap. All of the screws in Bedrok are now machine screws that are machined inserts into the Bedrok material. This means this deck can come apart and go back together again throughout its entire life. Okay, so we now have a few grounding cables that we can fit at this point. All turntables have to combat static electricity. So there are a few grounding cables on the LP12 to eliminate that. So at this point, we've done pretty much as we can with the deck this way up. So now we're going to rotate it and move it up to the correct orientation. So the first thing I want to do is just make sure that we're sitting level. This will be important later when we tune the bounce of the turntable. So now I can fit my speed control sensor. The optical sensor or tachometer monitors the rotational speed of the LP12 platter, feeds that information back to Radikal, the power supply, which in turn will control the speed. And now we can secure the tachometer. And it is now secured in place. Last thing we'll do here is to make sure that the cables are tucked under the arm so that nothing can interfere with the rotation of the turntable. Next thing we're going to do is we're going to fill our carousel bearing with oil. So we're going to start and put 20 drops of oil into the bearing, one at a time. Once we have our 20 drops, we're going to use the spindle of the inner platter as our dipstick. So I'm going to drop the inner platter carefully into place, and then I'm going to immediately remove it. I'm going to look at the oil shadow and see where the oil comes to. And in this case, I'm about 5 millimeters from the very top of the spindle. I want to be a little more than that. I want to be around 2 millimeters from the very top. So I'll try another 3 drops of oil. And I'm just going to keep rechecking the oil level until I'm happy. So again, drop the platter into place, let it get to the bottom of the bearing, and lift back out. And now my oil level is around 2 millimeters from the very top of the spindle. So I know I'm full of oil exactly where I need to be, so I can drop the platter back into its final resting place. The next thing we're going to fit is the drive belt. So I'm going to look at the drive belt, I'm going to hang it from my finger, look at the shape that it forms, turn it inside out, and look at the shape that it forms. And I want it to be less teardrop shaped, which I feel is this way. So that's the way I'm going to fit it. So around the smaller pulley and around the inner platter. It will sit on the bottom of the platter, but once the deck has weight on it, it will sink down and ride in the middle. Next up is Linn's Ekos SE Tonearm, our flagship reference level tonearm. And we're going to be fitting it with Ecstatic, our flagship moving coil cartridge. So Linn's high performance cartridges are a 3-point fixing, which makes life very easy. No geometry to check. Bolt the cartridge on and you're good. So with our arm in place, I'm now going to fit our outer platter. Carefully sit that onto the inner platter. So I've got 3 settings I need to set for my tonearm. The tracking force, pressing down at the cartridge end, the height of the arm itself, and the anti-skate bias that pulls the arm towards the right side of the turntable. So the first thing we're going to set up is the tracking force. So I'm going to very lightly lock my arm in place, just making sure it's parallel to the plinth. Now we're going to take my cartridge tracking force scales, and for the Ecstatic cartridge I'm looking for a tracking force of 2 grams. So carefully remove the stylus guard, and then I'm going to place it in the center of my scales, and I'm going to check our tracking force. 2 grams. Perfect. Now that we have our tracking force set for our specific cartridge, we're going to set the height of the tonearm. To do that, we're going to need a vinyl record. So I'm going to lift the arm up, place it into the middle of the vinyl, and drop it down onto the surface. And I can see that my arm tube is not parallel with the top surface of the vinyl record, which is what we're looking to achieve. So I'm going to lift that up, put the arm back in the cradle. I am going to unlock the arm, raise it slightly in the arm collar, gently lock it in place. I'm going to check one more time. So now my arm is completely parallel with the top surface of the vinyl. So I can remove it and secure the arm permanently in place. The last setting that we have to set is the anti-skate bias, and that's set by a small dial on the side of the arm. So for this cartridge in particular, that setting is 2 grams. So with that now set, I can put the stylus guard back on, and our arm is set up. So now that I have my arm fitted in place and everything is set correctly, we can look at the alignment and bounce of the LP12, the mythical bounce. There is nothing rocket science or voodoo about this. It is purely mechanical energy. What we're looking to do is to have the LP12 bounce completely vertically. No sideways motion, no front to back wave, but pistonic vertical bounce. So again, we can check our alignment, our level left to right, front to back. And if we need to adjust, we can make small adjustments to our springs, rotational adjustments. And each time I do that, the bounce of the deck will change. So what I'm looking to do is to bring my 3 springs into vertical alignment. So with those adjustments, I'm looking at the decay of the bounce. You will almost always put some sideways movement into the deck as you bounce it. But I'm watching the decay of the bounce, and I'm happy with my vertical movement. So at this point, I'm happy with the bounce of the LP12. Next thing I can do is I can fit my Urika Phono stage. So for this LP12 build, we're using Urika 2 Phono stage using exact link, and I can now get ready to slot my Phono stage into place. And we can secure it with machine screws rather than the wood screws that have been used in the past. And with the last screw in place, our LP12 is complete.